So welcome back. In this video we will discuss one numerical. According to the numerical, we want to plot the root locus for the given open loop transfer function. Here we have open loop transfer function g of s h of s equal to k over s into s plus 1 s plus 2. So already we have seen rules for plotting the root locus. According to the first rule, we know root locus is always symmetrical with respect to the real axis. So according to first rule, there is no calculation, so we can ignore it. So first we will calculate number of open loop poles and number of open loop zeros. So here we have three open loop poles. First at s equal to 0, second at s equal to -1, third at s equal to -2. So we have three open loop poles for the system. We don't have any 0 for the system, or we can say there is no open loop 0 for the system. Now let us see second rule. Already we have seen second rule. In second rule, we will decide total number of branches for the root locus. So here p is greater than z. That means number of branches of root locus is equal to number of open loop poles. So here we have three branches for the root locus. Now let us see third rule. According to the third rule, we will decide starting and ending point for the root locus branch. We know we have three root locus branches for the system. So first root locus branch starts at s equal to 0 and terminates at infinity as k tends to infinity, because we don't have any open loop 0. Similarly, second root locus branch starts at s equal to -1 for k equal to 0 and terminates at infinity as k tends to infinity. Similarly, third root locus branch starts at s equal to -3 for k equal to 0 and terminates at infinity for k equal to infinity. Now let us see fourth rule. In fourth rule, we will decide existence of root locus on the real axis. So first we will draw the pole 0 diagram. So here we have three poles at s equal to 0 and at s equal to -1, also at s equal to -2. We don't have any open loop 0 for the system. Now decide point P1 between s equal to 0 and s equal to -1. Now let us see total number of poles and zeros to the right of point P1. So we have one pole for the system. This is an odd number, so we can say P1 will lie on the root locus on the real axis. Now consider point P2 between s equal to -1 and s equal to -2. Let us calculate total number of open loop poles and open loop zeros to the right of point P2. We have two poles for the system. It is an even number, so we can say point P2 will not lie on the root locus on the real axis. Now consider point P3 between s equal to -2 and s equal to -infinity. Let us calculate total number of open loop poles and total number of open loop poles and total number of open loop zeros to the right of point P3. So here we have three open loop poles for the system. It is an odd number, so we can say P3 will lie on the root locus on the real axis. So we can say root locus on the real axis exists between s equal to 0 and s equal to -1. And beyond s equal to -2 or between s equal to minus infinity and s equal to -2. So this is our fourth rule. Now let us see fifth rule. According to fifth rule, we will calculate break away point. So in fourth rule already we have decided existence of root locus on the real axis. So we can say here we have a break away point between s equal to 0 and s equal to -1. बिकॉज जब हम s इक्वल टू 0 से रूट्स को व्यू करेंगे या पोल्स को व्यू करेंगे, हमें पोल्स दिखेंगे लेफ्ट साइड में फ्रॉम s इक्वल टू 0. जब हम s इक्वल टू -1 से पोल्स को व्यू करेंगे, हमें पोल्स दिखेंगे राइट साइड में फ्रॉम s इक्वल टू -1. दैट मीन्स दोनों पाथ एक दूसरे की तरफ मूव करेंगे. जब दोनों पाथ एक दूसरे की तरफ मूव करेंगे, एक ऐसा पॉइंट आएगा जिस पॉइंट पर पाथ ब्रेक हो जाएगा. उस पॉइंट को हम बोलेंगे ब्रेक अवे पॉइंट. दैट मीन्स हेयर ब्रेक अवे पॉइंट विल एग्जिस्ट बिटवीन s इक्वल टू 0 and s इक्वल टू -1. We don't have a root locus between s equal to -1 and s equal to -2. That's why breakaway point कभी भी s equal to -1 and s equal to -2 के बीच में लाई नहीं करेगा, बिकॉज रूट लोकस s equal to -1 और s equal to -2 के बीच में नहीं है. रूट लोकस s इक्वल टू 0 s इक्वल टू -1 के बीच में है, और रूट लोकस s इक्वल टू -infinity एंड s इक्वल टू -2 के बीच में है ऑन द रियल एक्सिस. तो पॉसिबिलिटी क्या है कि ब्रेक अवे पॉइंट s इक्वल टू 0 s इक्वल टू -1 के बीच में हो सकता है, या फिर ब्रेक अवे पॉइंट s इक्वल टू -infinity एंड s इक्वल टू -2 के बीच में हो सकता है. बट s इक्वल टू -infinity एंड s इक्वल टू -2 के बीच में नहीं होगा, क्योंकि s इक्वल टू -2 के बाद कोई भी पोल नहीं है, या यू कैन से देयर इज नो पोल बियॉन्ड s इक्वल टू -2. अगर हम केवल मैग्नीट्यूड की बात करें तो मीन्स अगर हम s इक्वल टू -2 से व्यू करेंगे पोल्स की लोकेशंस को, तो हमें पोल्स केवल लेफ्ट साइड में दिखेंगे फ्रॉम s इक्वल टू -2. और वी डोंट हैव एनी पोल बियॉन्ड s इक्वल टू -2. तो कभी भी रूट का पाथ एक दूसरे की तरफ नहीं होगा, इसीलिए s इक्वल टू -infinity s इक्वल टू -2 के बीच में ब्रेक अवे पॉइंट नहीं होगा. नाउ लेट अस सी, जब आप s इक्वल टू 0 से पोल्स की लोकेशंस को देखोगे, आपको लेफ्ट साइड में दिखेगी फ्रॉम s इक्वल टू 0. जब आप s इक्वल टू -1 से पोल्स की लोकेशंस को देखोगे, आपको राइट साइड में दिखेगी फ्रॉम s इक्वल टू -1. दैट मीन्स पाथ एक दूसरे की तरफ मूव करेंगे. दैट मीन्स कॉन्साइड होगा, और उसके बाद पाथ ब्रेक हो जाएगा. तो उस पॉइंट को हम बोलेंगे ब्रेक अवे पॉइंट. तो ब्रेक अवे पॉइंट s इक्वल टू 0 और s इक्वल टू -1 के बीच में लाई करेगा. सो ऑलरेडी आई हैव रिटन ब्रेक अवे पॉइंट will lie between s equal to 0 and s equal to -1. Now let us see how we can calculate the breakaway point. For calculating the breakaway point, first we will define a characteristic equation with the help of 1 plus g of s h of s equal to 0. G of s h of s be now it is k over s into s plus 1 s plus 2. Put the value of g of s h of s, then we have characteristic equation s cube plus 3s square plus 2s plus k equal to 0. From this equation, let us calculate the value of k. We have minus of s cube plus 3s square plus 2s. Let us differentiate k with respect to s and equate it to 0. So we have minus of 3s square plus 6s plus 2 equal to 0. यहाँ से आपको s की वैल्यू निकालनी है. वी हैव टू वैल्यूज फॉर s. फर्स्ट वन इज माइनस 0.42, सेकेंड वन इज माइनस 1.58. ऑलरेडी वी हैव डिसाइडेड break away point exist between s equal to 0 and s equal to minus 1. So minus 0.42 is a valid breakaway point. Minus 1.58 is not a breakaway point, because breakaway point s equal to 0 and s equal to minus 1 के बीच में लाई करेगा, इसीलिए breakaway point होगा minus 0.42. minus 1.58 breakaway point नहीं होगा, because ये s equal to 0 s equal to minus 1 के बीच में लाई नहीं करेगा. Now let us see sixth rule. In sixth rule, we will decide number of asymptotes with the help of formula P minus Z. P means number of open loop poles. We have 3. Z means number of open loop zeros. We don't have any open loop zero for the system. So number of asymptotes we have 3. Now let us calculate centroid with the help of formula. Sum of real parts of poles for open loop transfer function means 0, minus 1, minus 2. 0, minus 1, minus 2. That means minus 3. Minus 3 means sum of poles of open loop transfer function minus sum of real parts of zeros of open loop transfer function means 0, divided by P minus Z. P means 3, Z means 0. So we have centroid minus 1. Minus 3 means sum of real parts of poles of open loop transfer function. So we have poles at 0, at minus 1, at minus 2. So sum of real parts of poles of open loop transfer function becomes minus 3. Minus sum of real parts of zeros of open loop transfer function. We don't have any open loop 0, that's why 0, divided by total number of poles for the open loop system. That means 3 minus total number of open loop zeros, that means 0. So we have centroid minus 1. Now let us see next. According to 7th rule, we want to calculate the angle of asymptotes with the help of formula T2q plus 1 180 degree divided by P minus Z. Q वेरी करेगा 0 से लेके 2 तक. 2 क्यों आया? Because Q वेरी करता था 0 to P minus Z minus 1. P minus Z means 3, 3 minus 1 means 2. So Q will vary from 0 to 2. That means 0, 1 and 2. So we have 3 angles of asymptotes. First we can calculate after putting Q equal to 0. So we have 60 degree. Then we will put Q equal to 1 in equation. 2Q plus 1 180 degree divided by P minus Z. So we have 180 degree. Last we can calculate after putting Q equal to 2 in equation. So we have 300 degree. So angle of asymptotes becomes 60 degree, 180 degree, 300 degree. Now rule number 8 is not applicable because we don't have any complex pole. So we cannot calculate angle of departure from complex pole. We don't have any complex zero. So we cannot calculate angle of arrival at complex 0. So according to last rule, we will calculate intersection with imaginary axis. How we can calculate intersection point with imaginary axis, or how we can calculate intersection of root locus with imaginary axis with the help of Routh-Hurwitz criteria, or with the help of RH criteria using a characteristic equation. So first we will define characteristic equation with the help of 1 plus g of s h of s equal to 0. Put the value of g of s h of s. So we have characteristic equation s to the power 3 plus 3s square plus 2s plus k equal to 0. Now define a Routh array table with the help of coefficients of characteristic equation. So in reference column in Routh array, in reference column in reference column in Routh array, we will define all powers of s starting from s to the power 3 to s to the power 0. Coefficient of s to the power 3 1, coefficient of s to the power 1, that means 2. In second row we will write coefficient of s to the power 2, it is 3. Coefficient of s to the power 0, it is k. So we can calculate coefficients for row s to the power 1. 3 into 2, 6 minus k into 1, k divided by 3. Next we cannot calculate coefficient for row s to the power 0. We can calculate with the help of 6 minus k divided by 3 into k divided by this quantity. That means 6 minus k divided by 3. So we have k. Now according to Routh array table, we can calculate the values of k for a stable system, for unstable system, and for marginal stable system. So for a stable system, there must be same sign for the all elements. So we can say for a stable system 6 minus k over 3 must be greater than 0. So we have k less than 6 and k must be greater than 0. So we have k greater than 0. So if we combine both conditions, we can say we have k greater than 0 less than 6. This is a value of k or a range of k for which system is a stable system. Okay, or we can say conditionally stable system. For a marginal stable system, we have if k becomes 6 or k becomes 0. If k becomes 6, S1 row becomes completely 0. So we can define auxiliary equation from the previous row or from the row s to the power 2. So we have auxiliary equation 3s square plus k equal to 0. Put the value of k. So we have 3s square equal to minus 6. We have s equal to plus minus j under root 2. This will define intersection point of root locus with imaginary axis. And here we have k equal to 6. That means for marginally stable system. तो सबसे पहले हमने क्या किया, कैरेक्टरिस्टिक इक्वेशन फाइंड आउट की, उसके बाद में राउथ एरे फॉर्म की. राउथ एरे टेबल में स्टेबल सिस्टम के लिए सारे एलिमेंट्स के सेम साइन होने चाहिए, इसीलिए 6 माइनस के ओवर 3 0 से बड़ा होगा. दैट्स वाई वी हैव के लेस देन 6 एंड के भी 0 से बड़ा होगा. दैट्स वाई we have k greater than 0 less than 6 for conditionally stable system. Marginally stable system के लिए k की वैल्यू 0 होगी लास्ट रो से, या फिर k की वैल्यू 6 होगी फ्रॉम S1 रो. तो जब k की वैल्यू 6 होगी, S1 रो completely 0 होगी. That's why we can define auxiliary equation from the previous row. So we can define auxiliary equation with the help of rho s to the power 2. So we have 3s square plus k equal to 0. k की वैल्यू 6 है, ऑलरेडी हमें पता है, तो s की वैल्यू आएगी प्लस माइनस ये √2. दिस इज वैल्यू ऑफ इंटरसेक्शन पॉइंट विद इमेजिनरी एक्सिस. और यहाँ पर k कितना होगा 6 और सिस्टम कौन सा होगा मार्जिनली स्टेबल. जब k की वैल्यू 6 से ज़्यादा होगी तब सिस्टम क्या होगा हमारा अनस्टेबल. तब सिस्टम क्या होगा हमारा अनस्टेबल. नाउ लेट अस सी आपको प्लॉट कैसे बनाना है.